Okay, so the next part here, we're going to talk about the skills. So we're going to talk now about the skills for part 4C. So we have reciprocal graphs. The basic reciprocal graph looks like this. And if you want to know why, I would encourage you to quickly do a table of values for x and for y. If, for example, we put in a very large value here, like 10, then we will be doing 1 over 10, or 0.1. If we pick smaller values that are still greater than 1, 2, so we'll get a half, we'll get 0.5. So you can piece this together with positive, large and small, and negative coordinates, and you'll be able to generate this. And a new bit of terminology, which will keep coming up repeatedly, is we can talk about these lines here. You might be able to spot that it will never be the case that y is equal to 0 or that x is equal to 0. It will get very close, but it will never equal these. These are called asymptotes. So we have one at y equals 0. That's often known as the x-axis. So we have another vertical one as well. This is at x equals 0. And you can use this graph to help you sketch sort of more complicated versions of this. You can think of them being as transformed. So for example, if we make this negative, okay, negative 3 over x, it's going to move the right to the left, and here the left to the right. What's multiplying by 3 going to do? Well, it's going to stretch these graphs. So we can sketch this and notice there's no real points of interest on here. We could again mark the asymptotes, but there are no intercepts, and there's not much to write down on the actual sketch. So we can only sort of do this to a limited extent. Something that is new though, and to do this, I would encourage you, if you're unsure, I would encourage you to use your calculator. So I'm just going to show you that very quickly now. So if you are in the position of being unsure what a graph looks like, you can always go into table mode, type this in. So 3 over x, where are we? X squared equals g of x. You don't want to define that. We only need to define one function. And we can put some values in. So let's put in, for example, -5 to 5, going up in 1. And we can have a look at our coordinates, and we could generate our graph from this worst case scenario. Notice the error. The error shows you the asymptote. So this is what you would generate with a very basic, quick table of values. And the reason for this shape is x squared only ever gives you positive values. So that's why nothing is occupying the negative space. Over here, we are only going to occupy the negative space, and 4 is a stretch. So these are both called reciprocal graphs. On here, sketching them together, you could do this with a table of values to see the pattern. Very, very similar, but 3 means that this has been stretched. So each y coordinate is sort of multiplied by 3, whether that's in the positive or in the negative direction. So now you should be able to have a go at exercise 4C in the book. You can check out these links on the screen as well to help you a bit more. And you should also be able to finish off those alternative questions from before.